Hello again. We take a look at this question which is on characteristic and application of polymers. It reads like this. The tensile strength and number average molecular weight for two polymethyl methacrylate materials are as follows. The values for tensile strength in megapascals and number average molecular weight in gram per mole are mentioned here. You have to estimate the tensile strength at a number average molecular weight of 40,000 grams per mole. To find a solution here, to find the answer actually, we know that the governing equation here is Ts, that is tensile strength, is equal to Ts infinity minus A upon Mn. In this equation, the values of Mn here are given. So this is Mn values, and the value of tensile strength here, this is Ts, is given. In this equation, we have two unknowns. Ts infinity is unknown and A is unknown. So we have to have two data sets. So we have actually two data sets to find the answer. We have to arrange this equation in the format Ax plus By is equal to C. So we rearrange here. Ts we take here infinity minus A upon Mn is equal to, the constant values are given. So this is Ts. So in this equation, the Ts infinity value represents our x and the A value here represents our y. These are the two unknowns that we have to find out. Now to find these unknowns, we have to substitute the values in this equation two times to form two equations. So therefore, we write Ts infinity here minus A upon, so the first set, data set we take 30,000 is equal to Ts value is 50. Let's rearrange this slightly. So we write it as Ts infinity minus, this is a coefficient 1 upon 30,000 of A. That gives us simultaneous equation 1. In a similar manner, we make use of the second data set here, this data set, in order to form equation 2. So substituting values, we'll have Ts infinity minus again 1 upon 50,000 A is equal to 150. This is our equation 2. Now we know how to solve this equation. So here we choose the mode here for equation, that is equation mode, and the number of unknowns 2. Now the value of A1 here, this is A1, so the coefficient is 1. The value of B1 here, this entire value is the value of B1. This is the constant, this is the unknown, and this is the coefficient. So it's going to be minus into bracket 1 divided by 30,000 bracket complete is equal to, and then we feed the value of C, that is 50 here. Similarly, for A2 we have 1. The coefficient here is minus into bracket 1 divided by 50,000 bracket complete is equal to, and the value of C here is 150. So we get the value of X. Now X here we know is our Ts infinity, and that works out to 300 megapascal. And for Second part, Y. We know the Y here we have is A, and that is 75 lakh grams per mole. So now in order to solve this numerical, we have to substitute the values of Ts infinity and A, these two constants, in this basic equation, and then for 40,000 we find the answer. So rewriting this equation, to find the tensile strength, we substitute the values of constants, which in this case is 300 for Ts infinity minus, into bracket, A here we know is 75 into 10 raised to 5 divided by 40,000, because that is the asked number. So this, when you calculate, works out to Ts is equal to 112.5 megapascal. Now, if you take a look at the data sets, you'll find that for 30,000 number average molecular weight, the tensile strength is 50. And for 50,000 Mn value, the tensile strength is 150. This number 40,000 is in between 30,000 and 50,000. So we must have an answer in general between 50 and 150. It may not be midpoint depending upon the equation, but we have this value 112, which is less than 150 and more than 50. So this is the answer. Thank you.